So this might not be the ideal way to show these ideas, but I figured we'd try to introduce it. It's not an incredibly difficult concept, adding on the double bonds and the triple bonds, but it can get a little confusing sometimes. But I figure on a Friday we might as well give it a shot. So we've talked about alkanes, and you guys have been doing great figuring out how to name these alkanes. I have here this line angle model. So we have 1, 2, 3, 4, 5 carbons in the model. So we would call this a pentane. Whenever we start to add more bonds, doubles and triples, it changes the name slightly. So if we would call this, let's see if I can figure this out. We would call this right here a pentane. If we start to add a double bond, let's say we put a double bond here between the first and the second carbons, it changes the name in a couple of ways. First and foremost, that ane ending changes to ene for a double bond, pentene. If I was to add a triple bond here, I wonder if it'll even let me. Let's see if I can do it this way. A triple bonded compounds are called alkynes, so we would call this pentyne. Now, there's one other thing that we need to include, and I haven't done this in a great spot. I wonder if I can move this down a little bit. Let's just zoom it out. Not only do we have to show the fact that there's, say, a double or a triple bond in the compound, but we also have to state where it is. So in this case, I put the triple bond between the first carbon and the second carbon. So we would have to call it and identify where that triple bond is. We would call this 1-pentyne. Or if I switch it back, let's actually switch it. Or if I switch it back to a double bond, this was our pentene example, this would be 1-pentene. If I create a different compound, let's say, or don't even really have to create a different compound, let's just adjust where that double bond is. Now we've moved the double bond over between carbons 2 and 3. So we would have to call this a 2-pentene. Now if we clear this, remember it's same sort of ideas as before. If I was to then come over and move it over again, the double bond, at first it looks like that double bond is between carbon 3 and 4, but hopefully you guys are starting to see a little easier that, well, actually we would have to number from the right side and also call this a 2-pentene. When we're naming and doing branches, the double bond or triple bond for that matter take precedent, meaning, if I was to come over and start to add branches, right? Let's say I put a branch, let's see if this works. I need to click there. Let's say I put a branch here. I flipped it over. Interesting. So now we know that we have a methyl on potentially carbon 1, 2, 3, 4, 5. And we've been saying, okay, well, you want to make the branch numbers the smallest. Well, we also want to make the bond numbers the smallest. And as it turns out, the bonds take precedent, meaning I want to look at the molecule based on the bond first. So I wouldn't number this from the left side. I would have to number it from the right side. So that's carbon 1, carbon 2, 3, 4, and 5. And so in order to name this, I still have my pentene because it's 5 carbons long. That double bond is on carbon 2. And now we have this branch right here. A methyl branch off of carbon number 4. So we would add that to the front of the name. It would be 4-methyl. Hopefully I can fit it. 2-pentene. So like I said, it doesn't change anything that we've done so far. It kind of inserts itself as the major thing to identify whenever you're doing your numbering. So if we make up just let's just, I gotta get out of here. Let's get rid of all this stuff and let's make a quick compound. 4, 5, 1, 2, 3. Let's see, I think it's 6, right? Or is it still 5? Yeah, 6. 1, 2, 3, 4, 5, 6. So now we have a hexane. I'm going to change it to a hexene. And then let's put a couple of branches on. I can put maybe an ethyl here and a methyl here. Make it look nice. Maybe there we go. Longest branch. Always identify the longest branch first. We see this double bond, so I want to start numbering from this end. So I'm going to start my numbering here. We have 1, 2, 3, 4, and now I could branch one of 2 ways. It looks like they're the same length, so it doesn't really matter. We got 5 and we got 6. So ultimately, I know I have a 2-hexene. Identify my branches. I got a methyl on number 3. That looks like a 2-carbon branch, and ethyl on number 4. Remember, we put those in alphabetical order. I'm going to try to fit all this. So we have a 3-methyl. Wow, that was really bad writing. I feel like I should do that again. I wonder if there's an eraser here. There we go. Try that one more time. Give myself a little bit more space. 3-methyl. And then we put the ethyl in front of everything, so it'll be a 4-ethyl. And we have our final name. 4-ethyl, 3-methyl, 2-hexene. While we're at it, let's just do a quick double or a triple bonded example. 1, 3, 4, 5, 6, and 7. Make it look good. Throw a triple bond here. Couple easy branches, 1 and 2. We look at the numbering. This could be carbon 1, 2, or 3, or if we come from the other side, it's going to be what? Carbon 4 and 5. So we'll go from the left. 1, 2, 3, 4, 5, 6, and 7. So now we have a 3. Heptyne. Looks like a couple of methyl branches, one on carbon 5, one on carbon 6. This was another thing that I noticed a couple people are still making a little mistake on. We have 2 of the same branches. So that would be a dimethyl situation. We have one of them on 5 and one of them on 6. So we have to add this 5,6 dimethyl to the front of our name. see if I can space it right. 5,6 dimethyl. So my plan is I'm going to give you guys a couple of these to try after you look through the Nearpod, watch this video, and then if you have any questions, please let me know. I'll be available all day. Have a great day.